Hello, everybody. Thanks for coming to this talk we have on From Possibility to Production, Building a Strong, Flexible Foundation for AI Security. Imagine building the next breakthrough AI application, one that could transform your business, revolutionize your industry, reshape how we interact with that technology. And now imagine doing it with complete confidence in your security foundation. My name is Hart Rossman, Vice President of Security at AWS, and joining me later today on the stage is Becky Weiss, Vice President and Distinguished Engineer who focuses on AWS Identity Services. And we're excited to take some time today to talk about how you can build a strong, flexible foundation starting from wherever you are in your AI journey. Now, just a few years ago, generative AI burst onto the scene, and organizations faced a critical question. How do we innovate rapidly while maintaining security? Now today, Becky and I are going to show you how AWS and some of our customers have answered that question. And we'll show you how a strong, flexible foundation can take us into the next era of AI innovation. Now, we've seen remarkable evolution in how organizations approach AI security, from proof of concept all the way through to production. Those deployments are just fantastic. And as we examine the evolution of AI security, it's crucial that we take on this persona of living in the future, right? It's not really an aspirational statement, right? We can see where AI is going. We can look around corners and think ahead to the security capabilities we'll need in the future. And we can start implementing them today. So no matter what stage your organization is currently at, your security requires that you operate today as the industry will operate several years from now, right? There's no reason to wait. We must pioneer generative AI and machine learning into every aspect of our operations. It's an imperative in today's marketplace. At each stage, we need to focus on anticipating and shaping the future of security. No matter where you are in development, AWS can support your AI evolution. Right? Now, if you look at these three stages, from proof of concept to enterprise production, right? We encourage teams to start with bootstrapping their ideas using AI, building security in using AWS Cloud Services, and piloting ideas, right? This idea of bootstrapping, use generative AI to build generative AI applications, right? Then we move into scaling your implementations. We look at working backwards from both customer data and implementing flexible controls to drive both incremental and disruptive innovation. Now, as you begin your organization-wide implementation, we're seeing customers embrace AI-first mindset in how they envision, design, build, and operate their mechanisms, automation, and technology. It's a full-stack deployment using Gen AI. And this approach allows our customers to not just optimize for today, but really to lay the groundwork for future deployments while perpetually innovating. Right? Now, this isn't just a new wave of technological deployment and development. Right? Generative AI is allowing us to rethink that human-computer interaction. Right? As generative AI becomes deeply embedded across your organization, it's driving substantial economic gains, increasing productivity, as well as profitability. Now, customers are telling us that generative AI is becoming the connective tissue of modern enterprise architecture. It interfaces with virtually every workload, right? From compute and containers to databases and analytics, extending out to edge devices and IoT. This integration means that we really need security controls that work across the entire technology stack, right? It's important to remember the focus isn't just on the LLM, right? It isn't just on the coding assistant. We're building planetary scale distributed systems, and we want security architectures that work end to end and globally, right? Now, when you implement security thoughtfully for generative AI, you raise the security posture of your entire organization, right? By taking a secure by design approach, you're not just protecting the AI workload, as I mentioned before, but you're really strengthening security across that entire distributed system, right? Now, this is why we advocate for something you might have heard in the security community before, defense in depth, right? Something that extends across every layer and every integration point. As you heard yesterday in the keynote, right? Everything starts with security. And so it's not just about securing one application or one workload. It's really about building that comprehensive security foundation that enables innovation across the organization, right? So let's talk about defense in depth for AI, right? You can think of it in some ways like building a medieval castle, right? You don't just put up walls at the perimeter and call it a day, right? You want layers of appropriate protection, gates, guards, moats, each serving a distinct purpose, right? And so now with that medieval castle mental model in place, let's dive a little bit deeper in how defense in depth can be applied with cloud infrastructure. At the base layer, you're going to want to start thinking about your policies and procedures, and how do you onboard employees to this new way of thinking, training and awareness, right? We want to define the safety and security capabilities and priorities for the organization so that we've got clear direction. We can understand how to reason through and think about the controls that we're going to need, right? This is really important because generative AI use cases often are truly novel. They're things we haven't considered in the past. And so you can't just apply necessarily the previous policy or previous security control, right? And so now we have this opportunity, right, to consider internal and external use cases, right? How we're going to think about sensitive data in these systems, right? And other important drivers that your business might have in updating your policy, modernizing your training and curriculum, and bringing awareness and focus to your generative AI strategy and how security can drive it forward faster, right? And so the next layer we talk about is identity, authorization, access, right? We want to consider a variety of questions here, right? Should every API call have a guardrail, right? Which AI models can be applied to which specific applications and with which access rights? And as we move into the agentic space, are we thinking about agents more as employees of the organization or more as sophisticated automation, right? It's kind of early days, and we've got to reason through that. Right, now I know Becky, who's coming up a little later, is super excited about identity, so I'm not going to spend a ton of time here. But she's going to go into a couple of really great examples on how you implement identity in your generative AI stack. So we're going to move up the defense in depth stack here and onto infrastructure, right, on AWS. You need to be thinking about that infrastructure protection and strategy. We've well architected. You may have seen we have security reference architectures for generative AI. Right? And so all of those help you establish what that infrastructure, what that architecture starts to look like. And then we layer on network and edge protection, right? So what type of web application firewall are you going to put at a perimeter, right? Do you need proxies to do any data handling and manipulation? How are you thinking about resource management, whether it's token exhaustion or DDoS attempts on your application? Right? And what other types of network edge protection do you want as you think about content distribution from that generative AI workload out to your user community? Right? All of these are great questions to consider as you start thinking about the network and the edge. Now, it's not until you do all those things, get that foundation in place, where you start to think about how the application will handle data, right? And where are we going to apply things like guardrails? How are we going to handle sensitive data and whether we're going to choose to make it available for processing in plain text or, for instance, tokenizing or encrypting it? How do we think about safety and appropriateness and handling hallucinations if they occur at all, and other things that might be specific to the AI model that you've chosen, right? And why it's important to not just, again, think about the model security, but that overall end-to-end architecture and that logical information model, what's going to be passing in and out, right, of the model, and how some of those subsystems in the distributed system will handle it, right? These provide that secure foundation, that defense-in-depth architecture that gives you the confidence, right, to load critical data into the system. And then that brings us to operations, which includes threat detection and incident response, right? Your guard tower, if you will, to continually monitor the behavior and the status of the system. And so you might ask questions like, now that you've built out your application, how are your users using that application? What does that baseline of activity look like? And when do we see anomalies or deviations? Are they malicious, or are they just experimentation, right, from a cunning and excited user, right? Do we have users trying to do things like prompt injection or jailbreaks and malicious activity? And is that your pen testing team, or is that an unwanted participant in your system, right? And if you're building internal applications, right, how are they using the application, and what security metrics help get them the best user experience and the best outcome to drive innovation within your organization, right? Now, there may be certain areas, content types, based on your brand or how you want to interact with your users, your employees, your customers. And so you might think about putting guardrails in place to give the exact type of experience, the voice of your team or the voice of your organization, as you will, right? And so, to be able to do that, you've got to be able to look both at the input and the output. You're going to be examining not just the infrastructure logs like CloudTrail, for example, but you're also going to be looking at the prompt logs, right? And you're going to be looking at how is that conversation happening between the human and the computer, right? And then you're also in there doing a little bit of threat detection, right, and corrective actions. Now let's bring these defense-in-depth principles to life and see how organizations are building security into every layer of their AI implementation. We have this really cool customer, Trellix, right? They're a security leader, a customer, and a partner of AWS. And they had a number of customers who wanted to analyze thousands of security alerts daily. Now, they needed a solution that can maintain the highest security standards while dramatically improving operational efficiency for themselves and for their customers' experience. Using Amazon Bedrock and this AWS Security First foundational mindset, they transformed what used to be thousands of daily alerts into automated actions using their Trellix Wise product, an ambient AI agent. And now they did this while maintaining rigorous security controls at every layer of that defense-in-depth stack. What's even cooler, to be perfectly honest, is that they built this in just weeks. This wasn't like a multi-phase, multi-month project, right? And they used generative AI to write much of the code and replace complex workflows with simpler implementations and operations. At each layer of security, from the infrastructure protection all the way through to application control, right? They had that foundation in place, allowing them to really just focus on the feature set that was going to allow their application to do what it does best for their customers, right, in alert management. And so this is exactly what we mean when we say that AWS removes the heavy lifting of AI security, the undifferentiated heavy lifting. By building on our secure foundation, Trellix was able to maintain their high security standards while innovating at speed for their customers, right? Weeks, not months. And this isn't just about one particular company doing something super cool with AI to improve the security posture of their customers and themselves. It's really about this fundamental shift in how we think about AI and security working together, right? And so to tackle generative AI challenges, organizations have this opportunity to fundamentally shift their security mindset when it comes to this space. right? Imagine you've spent years perfecting your organization's security, right? You've got well understood policies, everybody's been trained, the infrastructure's in place, your controls are doing what they need to, the alerts are coming in, you've got that sense and response going in security operations. And now all of a sudden, you're asked to integrate in this new stack of technology, whether it's a language model or whether it's a coding assistant, right? And so now your existing security investments are going to help you, right? There are a few additional things, as we've been talking about, you want to take into consideration. And AWS is going to help you there, right? You're not on your own. Now, we don't want to think about this again as just another component in the system. It's an entity that can generate, interpret, and manipulate information in ways that traditional security models weren't really designed to work with, right? It's akin to introducing, in some ways, like a new employee or an intern who doesn't yet understand your policies or ways of working, right? And they have a point of view on how they want to get work done. And now you've got to negotiate that. You have the way you've been used to doing it, and you have this opportunity to learn, right, from a new perspective and a new experience. And in some ways, right, update that mental model and recraft the rules, right? AWS is no exception when it comes to looking at how we want to adopt and promulgate the use of generative AI in our organization, right? As you heard from Amy and George yesterday, our teams have been leveraging the same industry-leading LLMs that we offer to our customers through Bedrock and that our AWS services use to build tooling and offer features, some of which we've announced this week at Inforce, right? And they also talked about one example where we're now using generative security tests to examine large portions of the AWS API, right? And so, API landscape. And so let's take a couple of minutes to talk about how AWS was able to enable our teams very quickly to embrace this new technology in a safe, secure manner, right? One of the things we did was we early on got a number of different security stakeholders together in a room with our builders, with our leaders, to deeply understand the kind of use cases that they thought would be valuable, and for us to reflect on how can we match that with innovation and security. And as we began to do that collaboratively and together, we hit upon this idea of what we call secure build paths, right? It's this idea that for a set of use cases, we've got updated policy and guidance, we've got updated templates and guardrails and controls that if teams follow, they can innovate very quickly in a very, very secure and performant manner, right? And it's allowed some of the historical mechanisms that we use, like AppSec and operational readiness reviews, to go so much quicker now when you've got a generative AI application than we might have even done with a traditional application. Super exciting. And so each step of that secure build pathway supports our teams, right? Whether we're looking at use case assessment, model evaluation, architectural design and development, all the way through to deployment and operations, right? And so we were able to use security as an enabler here to really help our teams across AWS build quickly and build securely. And with that security-first mindset, we also needed to understand the paradigm shift that was happening between that traditional security workload and now these new generative AI security workloads. And because we worked early on to understand each other's points of view, right, and leverage the fundamental ways we were doing security already, we could just focus on some of the differences and some of the changes and enhancements we wanted to make to ensure that we could build these systems, right, in a way that is comfortable for both our developers and meets the very high security expectations of both our internal and our external customers, right? And there are three things that we kind of learned through that process, through that activity. And I'd like to share with you those right now, right? So first, let's consider the outputs of the system. Now, while traditional APIs operate with predictable formats and well-documented I/O patterns, input-output patterns, generative AI is based on natural language, right? Which makes it very accessible. but it also means that users can phrase their queries in countless ways. It's really unstructured, which also results in varying responses depending on the question format and the context that you provide along with that natural language prompt. The second thing we ended up thinking a lot about was that responses, we've got different levels of predictability, right? In traditional systems, they give us consistent, deterministic responses for identical queries, right? You're gonna always get the same answer unless the underlying data changes, right? But now with generative AI, responses can vary even for the same question. And so that introduces, some additional ways of thinking about how do we want to handle the output, right? Finally, there's the matter of authorization and data handling, right? Traditional systems, as I'm sure many of you are familiar, use role-based access or attributes-based access, RBAC or ABAC, to control that access to the data. With generative AI models, though, it's a little bit different because you're providing access to the model itself, not the underlying data that it was trained on, really. And so when you're thinking about authorization, right, you've got to consider that there's already a bunch of data that's in the system, right, in that LLM, that the user will necessarily have access to. And so now you're thinking about things like, how do you handle model context protocol? How do you handle RAG, right? The inputs and outputs in the prompt and the user, right? And so these three differences really provide a bit of that paradigm shift that you need to think about as you're building the strong defense and depth architecture for those generative AI workloads, right? To tackle this paradigm shift, again, back to this idea of a trusted foundation, you want to start building security in from the beginning, right? And the AWS Nitro system is probably the best example of AWS security philosophy in action, right? You don't get much more of a foundation than the hardware itself. With Nitro, we've built that specialized hardware that sits outside the Linux kernel, fundamentally redesigning how a hypervisor operates, right? It provides a level of security that just isn't achievable with traditional software-based hypervisors. This includes a variety of features that ensure hardware-based isolation, system boot at station, passive communication design, and no operator or SSH access. And all of this is built to provide the right level of security, right? From the hardware all the way up into the application stack, right? Which is pretty exciting. The beauty of this system is that it provides the underpinning for innovation. When you know you have that secure foundation, you can focus on pushing the boundaries of whatever your business needs to do with generative AI. And as we look to the future of AI, whether that's more sophisticated language models, agentic, or technologies we haven't even imagined today, this security-first architecture means we're ready for whatever comes next. Now, building on top of Nitro, it's also about how AWS hosts the models for our customers with our managed services, right? So just like we want to have strong foundation, strong policy and procedure, we also want to understand how those models are being selected and how they're being protected as we host them for our services like Amazon Bedrock, right? Now, Amazon Bedrock hosts a broad selection of fully managed models, including Amazon Titan and Nova models, Anthropic's Claude, Meta's Llama, and a number of other just fantastic models, as well as the Amazon Bedrock Marketplace, which gives access to more than 100 additional specialized models, right? So what goes in to the approval process for a new model on Bedrock? I'm glad you asked. I'll be happy to tell you. So it starts with AWS having a strict set of requirements for the format of the software package for the model. And then models are hosted in dedicated service accounts with no external internet access. We implement strong logging for all models to validate what it's doing, be able to operate it efficiently and effectively. We implement standard input validation to prevent scripts from being translated in the parser and running arbitrary code. And we have IAM roles to prevent unauthorized access. Now, across all of this, we make sure that we put security first. and we have the right security mindset in play, each layer of the stack, to provide the capabilities that customers have asked for with model hosting. Now, with that security-specific mindset in mind, right, model onboarding extends to industry-specific requirements. That's why last week we were thrilled to announce that AWS is the first cloud provider to achieve FedRAMP High and Department of Defense Cloud Computing Security Requirements Guide Impact Level 4 and 5 authorization for Anthropic's Claude and Meta's Llama foundational models in the AWS GovCloud regions. This milestone will transform how our US government customers harness the power of artificial intelligence for their workloads. Now, beyond that model hosting and its inherent security, organizations need to think about comprehensive safeguards for their AI applications, right? AWS provides 3 key capabilities to make responsible deployment safe and easy, right? First, Amazon Bedrock Guardrails is a fantastic capability that allows you to evaluate prompts and model responses. Remember that input and output from earlier, right? To look at undesirable content, help you identify and explain factual claims, and help define topics that maybe you want to limit, right, user access to. Help remove data types that you don't want being emitted, perhaps like personally identifiable information. Right? Then there's validation, right? A really important set of capabilities. Right? How do you think about preventing malicious actors from doing cross-site scripting or SQL-style injection attacks? AWS has capabilities and services like our web application firewall that are going to support the prevention of these types of attacks. And then we have automated reasoning checks, one of my favorite set of capabilities, to be perfectly honest. Using automated reasoning checks, we can verify compliance against factual claims. Using logic-based algorithms and mathematical validation, Amazon Bedrock Automated Reasoning validates the LLM outputs against domain knowledge encoded in policies to help prevent factual inaccuracies. You can think about automated reasoning like your AI application's security mathematician. It's constantly working to prove that your application and controls are working as intended and expected. Now, while filters and other checks work at the syntactic level, automated reasoning checks work at the logical level by validating responses against formalized policy rules. Right? What that means is it provides a more robust form of defense in depth for the entire system. Now, this 3-layered approach to application safeguards gives you greater confidence to innovate while maintaining strict security controls. Let's take a minute to dig in a little more deeply and bring this concept of automated reasoning to life with a real-world example from one of our partners, PwC. Now, they're using Amazon Bedrock's automated reasoning checks to revolutionize workloads across a number of industries. Today, though, what I'd really like to focus on is how they're applying it to pharmaceutical content development. PwC has integrated automated reasoning checks for mathematical verification of claims, tactics, and review processes, and they're able to generate policies for medical, legal, and regulatory reviews directly from approved labels and create guidelines based on regulatory documents like FDA warning letters. They're then able to take that system and run secondary checks on AI-produced content, mathematically verifying its compliance and veracity. Bedrock Automated Reasoning also validates new claims against an approved claims library and applies a chain of verification workload to ensure that each claim meets regulatory standards. So this acts as a second line of defense to sort of evaluate the evaluators or check the checker kind of activity. And it's all done automatically, right, without the need for a human in that loop. And so automated reasoning is still in preview, but PwC is already seeing the dramatic acceleration in their content to market timelines while validating regulatory compliance. It's super cool. And so what used to take months can now be done in a matter of weeks. This level of assurance is game-changing. It allows organizations to confidently deploy innovative AI in highly regulated environments, accelerating time to market while reducing risk. And this is really the future of AI security, right? It's where mathematical certainty meets business innovation. And it's available in preview today on AWS. So now that we've laid out the groundwork, let's do that deep dive into how we implement some of this defense in-depth architecture. I'd like to invite my colleague, Becky, to dive deeper into how we translate these concepts into action. And as she comes on stage, you might ask the question, did we use Amazon Nova to choose our outfits today? And I will let you know, this look was lovingly handcrafted by two friends in humans.
Yeah, so if you thought you were done staring at these overalls, I got news for you. Thank you so much, Hart. So as Hart emphasized, the foundation of any secure AI implementation starts with the right policies, procedures, and awareness. The bedrock, if you will, that's required to build anything with generative AI. Yeah, sorry for that. So this isn't just about technical controls, is the point. It's about creating a culture of security that permeates each and every aspect of your AI development and deployment. So, policies, procedures, and awareness. Policies. These are your guiding principles. They define what you're even trying to achieve with AI in your organization and then set the boundaries for how you're going to achieve that securely. Procedures, these are what you think of as playbooks. They outline step-by-step processes for implementing AI securely, from data handling and access to model deployment. And then finally, awareness. It's about education and culture. It ensures everyone in your organization understands the unique security challenges of AI and each of their respective roles in addressing them. So we're going to look at how you can put these together in practice, because I'm actually going to talk about Amazon, my employer. And we're going to talk about how we at Amazon approached the implementation of generative AI in our own organization, because like all of you, we stand to reap the benefits as well. And there's no better example than our journey with Q Business. Okay, so internally, AWS and Amazon introduced a few different generative AI applications built on Amazon Q for Business with a security-first implementation. These applications, they're internal generative AI applications meant to enhance the productivity of our employees doing all the different jobs that they do. And our goal here was to enhance employee productivity while protecting our highly confidential data. So we wanted employees to be able to summarize documents and ask their questions about a variety of topics. And therefore, the only way you're going to do that is effectively is to integrate it with your internal data sources. So we needed to integrate Q Business with those respective internal data sources. And on awareness, we launched comprehensive employee training programs, provided clear documentation, and also, importantly, created feedback loops for continuous improvements. Now, the enablement of Amazon Q Business for internal use cases has been a joint collaboration between Amazon and AWS. And let's talk about what we've built. I'm going to give you a few examples of what we built and actively use across both organizations. And I'm actually going to, because we have a security builder crowd here at Inforce, these examples are drawn from generative AI applications that we've built to enhance the productivity of our own security builders at Amazon. So we have the Amazon, so these are internal applications. We have the Amazon Security Operations Triage Assistant. So that improves the efficiency of the security response process. It helps data-driven decision-making, and it assists in continuous improvement of our detections. Another example is the Amazon Security Companion. So that's an enhanced search functionality and streamlined approach to summarizing the most pertinent information from the retrieved search results. So that equips builders with a head start in addressing queries and minimizes time spent on the kind of research that you have to do to get started on any security issue. And then finally, the CNA Guru. So that analyzes CVEs and provides things like CSS scoring and metadata and explanations for security engineers to evaluate. So these are just some applications that we deemed useful for our own security staff that we wanted to deploy to help them be effective. So how do we make that happen? So again, I'll reiterate that we're talking about data that we've classified as highly confidential, which means that the bar for protecting that data that we needed to meet was quite high. So first up in our considerations is the fact that all of these applications are built on Amazon Q. Now, Amazon Q is an AWS service, and that serves as an important security tailwind because like every other AWS service, and Amazon Q is no exception, every AWS service goes through extensive security reviews. It has to meet our security bar for AWS. So our application security, AppSec, process is a deep engagement, a deep and ongoing engagement with security engineers, where we walk through every aspect of the application architecture and look specifically for the kinds of things that can go wrong when a customer, which would be an internal, an employee of Amazon, uses the application. By building a top queue, an AWS service, the AWS Security Foundation is built right in. So you already have that going for you. So that's the foundation. But of course, as you know, there's a whole application being built on top of the foundation, and there are considerations that exist within the application itself. So we had to think about use cases. What are our great employees of Amazon going to do in these applications? For an example, like one desired use case was an internal chatbot that employees could use to answer questions or write documents, and again, potentially using our highly confidential data. And we wanted this chatbot to be able to summarize documents, answer questions about specific AWS or Amazon policies and topics without concern of leaking sensitive data. So that's what we did want. And then there's a bunch of things we didn't want, right? So one thing that these applications were not going to be plugged into user-specific information, because of the nature of what they did. You certainly don't want the users of it asking questions, asking user-specific topics, because it doesn't have the information that it would need to provide any accurate or useful answers there. So we didn't want our applications trying to answer those questions that it couldn't, so we put topic guardrails in place to block those kinds of questions, to prevent simple misinformation. Same goes, of course, for controversial topics, so that was also something to consider. So we implemented guardrails across different controversial topic areas that just prevent users asking questions about those things too. And the list goes on, and that's where policies, procedures, and awareness became important, even for these internal use cases. And we talked about established policies before, and they include, of course, data and access controls. So we're using internal data sources here. And of course, in a large company like ours, or even a medium or even a smaller company, not everybody has access to everything. So we need to make sure that each user of the application is able to interact with and access data, only that data to which he or she is originally authorized. Now, as you might imagine, building and deploying these applications also required some iteration over time and a commitment to iteration and feedback. And one great way to get feedback early is, of course, a beta program. So we did that internally. And because you never know exactly how people are going to use your applications, what types of questions that they'll ask, or any other considerations that you just may not have occurred to you during the design and planning phase. So in both the internal beta program, as well as on an ongoing basis, we monitored the application. So that was another key component. We watched what types of questions were coming in, what types of responses were going out, and we actively solicited feedback, of course, from the users. So one of our early beta audiences here was our security builders. And what do you think happens when you give security builders early access to some kind of generative AI application? They try input validation, let's say. They tried a bunch of input validation type cases, including cross-site scripting and things like that. So we made sure that the security controls and guardrails included these types of concerns. So monitoring and actively soliciting user feedback. Of course, that's not a new best practice for generative AI. Any internal business, any user-facing product benefits from these kinds of practices. But they're all the more important when we're talking about something so innovative, so new in the world, just really learning about what your users are going to expect from these new applications. So that's how policies, procedures, and awareness came into play with these applications. But I'm going to take you one step deeper into the defense in depth strategy that made our adoption of Amazon Q business applications successful. I'm going to focus on one of my favorite topics in AWS because it's what I work on. Let's talk about identity. All right, any modern business application, this isn't a generative AI thing, any modern business application already authenticates its users and usually has some notion of authorization. This user can do this and that user can do that. In an AI application, such as the one we've been discussing, the authenticated user identity will affect what each user can do and what data he or she can access, and maybe also how the system exactly is going to interact with him or her. So if you follow a lot of the chatter around agentic AI, you might have heard that there are actually two identities in the mix in a typical generative AI application. So there's the one you're probably thinking of, that's the human identity, that's the authenticated user who is using this application right now, but then there's also an application or machine identity, a non-human identity, and each of these actually matters. So there's human identity. So as the caterpillar in Alice in Wonderland would say, who are you? As we security builders might ask, are there any role-based permissions or access levels associated with who you verifiably are? And these will usually vary from user to user, right? We don't all have the same job at Amazon. There's lots of different jobs for people at Amazon. An employee in your finance organization is going to have access to different data and ask different kinds of questions than an employee in the sales organization. But then, so that's human identity and the authorizations to the human, but there's another plane here, which is the identity of the application. That identity provides the context around what the user is trying to do and may in fact affect what data you surface to that user. So if you're thinking that these same identities, human identity and application or non-human or machine identity, were already there in traditional workloads, you're absolutely right. This isn't actually that new. Surfacing the right data to the right user in the right context has always been an important goal. So what is new for generative AI here? Well, there are a few new things, right? It might, for example, affect the types of security guardrails and model controls that need to be in place, right? Because these are new concepts here. So it's a new kind of question to consider from your organizational perspective. So we have some parts we can think of as traditional security considerations for internal business applications that you may have, already built up practice and expertise around thinking about. And then some other parts that are new for generative AI. Let's talk about how that works in practice. So I'm going to show you here kind of the conversation before the conversation as a user steps up to, maybe some kind of generative AI application. These are the things that get figured out before the application starts. So a user navigates to the generative AI application, perhaps, maybe in a web browser or something like that, and say that they have yet to authenticate. So the application sees there's no authentication session here yet. So the user needs to be authenticated. So a typical application will redirect the user to your organization's identity provider. This is a pattern called single sign-on, SSO. And what will typically result from that interaction is an identity token is issued by the identity provider, and then the user is redirected back to the application, and the application now they not only have the user's identity in a verifiable token, it says this is Becky, but can also, with the help of the identity provider, find out other attributes or claims of the authenticated session, that might be relevant. So their role, their department, maybe possibly many different group memberships that kind of might reflect what they're working on. And given all of these claims, it's now possible for the application to make some authorization decisions. So depending on how sophisticated this application is, it might be making decisions about which users can access which functionality within the application. And certainly the user's identity and other identity-related claims are going to affect what data that user should be allowed to access. If you and I are on different teams in the company, we're probably going to have access to very different data sets. So now we've established a session, the user interactions can begin. So this session, now that it's been established, is going to have different defined boundaries and security guardrails, perhaps even different ones based on the profile of the user. So that's how the sequence of security checks occurs in general. Let's talk about how it works in Amazon Q business in particular. So Amazon Q, like I said, an AWS service. And again, it inherits all of the security goodness that all other AWS services have. For example, every AWS service has IAM policy checks at the gate. Q is no exception. So after the IAM policy checks and decisions about custom security guardrails and data access controls, after that, there might be some filtering of the response. So these are, what you're seeing here is multiple layers of security, and they're all working together. Now you also have to think about application identity. Now here, to sort of illustrate how this works in AWS, I'm showing you a request to Amazon Bedrock, to its core API called Invoke Model. This is the core Inference API in Amazon Bedrock. When we're talking about Bedrock's Invoke Model API or any of the thousands of others of AWS APIs that exist, application identity is established through AWS IAM. The request that reaches Bedrock, before it reaches Bedrock on the client, it gets signed according to our signature v4, SIG-v4 protocol. The client will sign each request with its IAM credentials. Now, typically, you as the builder don't need to do that directly because you're using one of our SDKs, our CLI, maybe you're going through the console. All of those things take care of the signature details for you, but that is actually what's happening. And it establishes a verifiable application identity. A little bit more detail on that and what happens when Bedrock, or really any other AWS service, receives one of these signed requests. So you can see that internally, Bedrock is making a request to the auth runtime service. Now the auth runtime service, this is not an AWS service that you've ever used. This is an internal-facing, large scale service that we run in each and every AWS region. This is the data plane of IAM, if you're familiar with those concepts. So ours validates the signature, then returns any IAM authorization policies from IAM that are attached to the authenticated caller or principal, or any policies attached to their account or their organization. There's a lot of policies that come back from the auth runtime service. And Bedrock, like all of our other AWS services, is integrated with a shared auth runtime client library that performs authorization of the request and all of its properties against those IAM policies. So it's a match of the request and all of its properties as prepared by Bedrock against all of these policies that came from IAM. So this policy, for an example of what the policy might say, it might require each invoke model to require a guardrail as part of each request, or else it will be denied. So what I'm telling you about Bedrock here, there's actually nothing special about that with respect to IAM. Every AWS API works this way. And so for AWS Generative AI services, this process is providing authentication and authorization for the application using existing techniques that if you're a builder on AWS, you're already working with today. We just saw authentication and authorization, and I'm going to just recap that part a bit. So we discussed how these applications might authenticate their human users using single sign-on, SSO, or similar patterns. We talked about how that user's identity might affect their access to data, as well as the guardrails and other behaviors. And then finally, how the application's identity fits in. That provides some context around how this user is interacting with the system. AWS services use IAM for authentication and authorization of applications. Now I'm just going to go out on a limb here and guess that many of you have heard of Agentic AI. With Agentic AI, the interesting thing here is that systems start acting autonomously. They might make decisions and take actions on behalf of users. Now, we're security people here at Inforce, so if you think about the implications of that, you can see how it adds a whole nother dimension to our authentication and authorization needs. Once again, a couple different identities here. The agent, for example, is going to be an entity that needs its own identity. And then at the same time, it needs to be able to take action on behalf of the user it's representing, meaning it needs to work within those constraints. So once again, we got multiple, maybe 2 or more identities going on here. And so in order to be able to do that, we're going to need a means of identity propagation. The original user's identity is going to need to propagate through the agent securely to all the systems and the data that it accesses. Now, that matters for 2 important reasons. It matters for authorization. So we want the agent to access the data that the current authenticated user has access to, but not any data or actions that this user didn't originally have access to. But within bounds, actually. Typically, an agent, you don't want it to, the agent has some sort of job, a particular context in which it's operating. You don't want it to have access to the full scope of all of the permissions that the user himself might have been directly entitled to. And it also matters for audit. Right, if you go to the audit logs, now in AWS, as you know, if you go to the audit logs, that means you're looking at CloudTrail events. If you go to CloudTrail, you want each access to be attributed directly to a user, because that makes it much more straightforward to answer the question of who accessed this data. So the good news is that AWS has been investing in identity propagation for data access use cases, especially in analytics, for a few years now. We have a feature called Trusted Identity Propagation. This capability allows any agent, including an AI agent, to securely propagate an end user's identity so that authorization decisions and audit can be made close to the data and reflect the user's identity. So let's see how those identity and agentic AI principles work in practice. Robinhood is a company committed to democratizing finance, and they were looking to enhance their financial crimes investigations. So they built a fin crimes agent on AWS. AWS's cloud-native tools and customizable foundation model services enabled Robinhood to rapidly experiment, fine-tune, and deploy AI agents tailored to compliance workloads without compromising on control or data security. So what makes the Robinhood implementation particularly noteworthy is their approach to comprehensive agentic identity controls and security. So they built a multi-layered system where there's a control plane with operational plans to enable deterministic agent behavior. There's an execution plane for self-contained agents orchestrated through Kubernetes. And then finally, there's a validation layer where every LLM agent includes a validation counterpart that reviews generated content for hallucination risk and consistency. So each agent operates with specific documented permissions and clear operational boundaries, and that enables fin crimes investigations to scale intelligently, respond to shifting risk patterns rapidly, and maintain transparency in every decision along the way. The results that Robinhood has achieved speak to the power of this security-first approach. Robinhood saw a 20% efficiency gain in investigative workloads while maintaining full regulatory compliance. They had complete audit trails of all agent actions and verifiable and explainable outputs. So when you build security and identity controls into your AI architecture from the start, you can enable both innovation and compliance. So we talked about identity and access management. I'm going to go to the next type of core protection: threat detection and incident response. Now, if you're a security practitioner, which you probably are because you're here at Inforce, these concepts are familiar to you. And just like authentication and authorization, it's built on your existing expertise with a few new concepts to think about that are specific to generative AI. So to our traditional incident response techniques, we need to add some AI-specific detection patterns. These include prompt injection attacks, model jailbreak signatures, model behavior anomalies, and unauthorized data access sequences. An appropriate automated response might dynamically block queries, adaptively rate limit requests, or generate alerts in real time. So both before the generative AI era, and now that we're in it, one of the great reasons for building on AWS is that you benefit from our deep, broad, and long-term investments in threat intelligence. Of course, threat intelligence is most valuable when it's, used. So our approach, therefore, is to build threat intelligence into our security tools. So the capabilities you see up on this slide, each of them is powerful and rich, and they make threat intelligence available, timely, actionable, and practical for all of our customers. And we share this critical information with customers that we believe may be targeted or compromised by potential malicious activity. And we help them take steps to reduce their risk and prevent disruptions to their organization. Matter of fact, we even notify organizations who aren't our customers if we see signals that they may be compromised, because we have a strong interest in making the internet safer for all its users. So we at AWS and you, our customers, are heading into this new era of AI together. So Hart, why don't you come back up here and tell them more about how we, AWS, understand security for this future.
Cool, thanks so much, Becky. I would love to. Awesome job, thank you. So as now we look to the future of AI security, we're seeing an evolution in how organizations need to think about protection. So let's talk about our perspective on where we're headed. The evolution of generative AI has followed a very clear progression, with each phase bringing new priorities and challenges for our businesses. With AI assistance, customers are experimenting with generative AI to identify where they can drive value, and they're building lots of proof of concepts, which is exciting. Customers are turning these AI applications into production workloads, right? And then they're turning their focus to operations, right, and optimization. Then scaling AI investments into Agentic, as Becky was talking about just a few moments ago, we continue to evolve towards a fully realized agentic world where we have intelligent, multi-agent systems that are going to make complex decisions and coordinate effortlessly with less human oversight, completely transforming the way we work and innovate. And we expect to see the rate of agentic AI adoption rapidly increase over the next several years. The key message here is do not wait. Start building your security foundation now. Take advantage of the investments you've already made. Organizations will thrive in the agentic era if they embrace security as an enabler of innovation. And if you build flexible, adaptable security architectures and implement these defense-in-depth approaches we've been discussing today, narrowly scoped privilege and secure access to those agents and foundational models, right? Security isn't just about protection these days. It really is about enabling the future of AI innovation. AWS is committed to being your partner on this journey. We've designed to be the most secure infrastructure for whatever comes next in the AI evolution, right? Now, as we look to the future of AI, AWS remains committed to our foundational principles of building security and privacy features across our infrastructure. And we're also continuing to collaborate with industry on developing standards and practices that strengthen AI security for everybody, right? We're founding sponsors of the Coalition for Secure AI. We continue to contribute to OWASP, and we're members of the Frontier Model Forum, as well as other industry standard projects that help define the next generation of security standards and best practices that will be crucial as AI becomes increasingly central to how organizations operate and innovate together. And when it comes to open standards, it runs deep in our DNA here at AWS. It's why we decided to build Amazon EC2 as a protocol-agnostic cloud computing service, and Amazon SageMaker as a framework-agnostic deep learning service. Our commitment to openness continues as we enter the agentic era, and extending to inter-agent communication. You might have heard multiple protocols that are emerging that enable this type of capability, including the Model Context Protocol, open sourced by Anthropic in late 2024. Now, demonstrating our commitment to these open standards, AWS is joining the steering committee for MCP. By supporting multiple protocols, we ensure developers can build breakthrough agentic applications without being tied to one standard and with having confidence in the security of that foundation. And just last month, Amazon announced the release of Strands Agents, an open source SDK that takes a model-driven approach to building and running AI agents in just a few lines of code. Strands scales from simple to complex agent workloads and from local development and deployment into production at scale. So now I want to bring us back to where we started, because it's a principle that underpins everything we do at AWS. Security is our top priority. Security is a commitment that we've long held true from the beginning, and it's no different when it comes to AI. Today we've explored why AWS has become the trusted foundation for AI innovation, powering everything from startups to global enterprises. We've seen how organizations like Trellix, PwC, and Robinhood are building transformative AI applications on AWS while maintaining the highest of security standards. But perhaps most importantly, we've discussed how we're continually evolving our security infrastructure and mental models to stay ahead, because in the world of AI, we all need to be living in the future. Thank you for joining us today. I hope you enjoy the rest of Reinforce. There's still a lot more that you can take advantage of today. I hope you think about how you can create that defense in depth in your AI journey, and remember to stay flexible, adaptable, and of course, keep learning and evolving. As I mentioned a moment ago, there's still plenty more to experience here at Reinforce. If you stay here, coming up next is a talk on AWS Global Threat Intelligence. A little later today, Anthropic's head of risk governance is going to be talking about how they collaborate with AWS to deliver enterprise-grade security for their LLMs and generative AI workloads for customers, right? Or if you're interested in hearing more about Robinhood's journey, you can join me, as well as their CISO and deputy CISO, later today, as we're going to talk about how they use security to drive innovation in a fast-paced fintech environment. Whatever path you choose, in the world of AI, security isn't just a feature. It's that foundation that enables true innovation. So thank you again. Enjoy the rest of the conference. And if you don't mind, please fill out the survey available in the AWS Events app so Becky and I can learn and grow from this experience as well. Thank you very much, and be well.